Activation of hypoxia-inducible factor 1 attenuates periapical inflammation and bone loss. Kimito Hirai, Hisako Furusho, Kiichi Hirota and Hajime Sasaki. International Journal of Oral Science Volume 10, Article Number 12, 2018. DOI 10.1038/4136818-0015-0. Abstract. Hypoxia, low oxygen level, is an important feature during infections and affects the host defense mechanisms. The host has evolved specific responses to address hypoxia, which are strongly dependent on the activation of hypoxia-inducible factor 1, HIF1. Hypoxia interferes degradation of HIF1 alpha subunit, HIF1 alpha, leading to stabilisation of HIF1 alpha, heterodimerization with HIF1 beta subunit, HIF1 beta, and subsequent activation of HIF1 pathway. Apical periodontitis, periapical lesion, is a consequence of endodontic infection and ultimately results in destruction of tooth-supporting tissue, including alveolar bone. Thus far, the role of HIF1 in periapical lesions has not been systematically examined. In the present study, we determined the role of HIF1 in a well-characterized mouse periapical lesion model using two HIF1 alpha activating strategies, dimethyloxylyl glycine, DMOG, and adenovirus-induced constitutively active HIF1 alpha, CA-HIF1A. Both DMOG and CA-HIF1A attenuated periapical inflammation and tissue destruction. The attenuation in vivo was associated with downregulation of nuclear factor-κappa B, NF-kappa B, and osteoclastic gene expressions. These two agents also suppressed NF-kappa B activation and subsequent production of pro-inflammatory cytokines by macrophages. Furthermore, activation of HIF1 alpha by DMOG specifically suppressed lipopolysaccharide-stimulated macrophage differentiation into M1 cells, increasing the ratio of M2 macrophages against M1 cells. Taken together, our data indicated that activation of HIF1 plays a protective role in the development of apical periodontitis via downregulation of NF-kappa B, pro-inflammatory cytokines, M1 macrophages and osteoclastogenesis.